Good morning. It's June 27th, and this is your daily brief in science. Here's everything you need to know. Scientists have made a groundbreaking discovery that could redefine our understanding of Earth's early history. They have identified rocks from the Nuvvuagittuq greenstone belt in Canada, estimated to be approximately 4.16 billion years old, potentially making them the oldest known rocks on the planet. These findings challenge the previously accepted oldest rocks, the Acasta gneiss complex, which date back about 4 billion years. If confirmed, the Nuvvuagittuq rocks may represent the only surviving crust from the Hadean Eon, a critical period in Earth's formation. Published in the journal Science on June 26, 2025, the study employed advanced dating techniques, specifically samarium-neodymium isotopic analysis, to establish the ancient status of these rocks. Both dating methods used yielded consistent results, reinforcing the reliability of the estimated age. Previous research had produced conflicting estimates regarding the age of the Nuvvuagittuq rocks, with some suggesting they could be as old as 4.3 billion years. However, concerns about potential contamination in earlier methods led to debates about their true age. The Nuvvuagittuq rocks are situated on Inukjuak tribal lands, where the local Inuit community has limited access to protect the site from damage. Community member Tommy Palliser emphasized the importance of collaborating with scientists to establish a provincial park that would safeguard the area while allowing for ongoing research. Experts in the field have hailed these new findings as significant, providing insights into Earth's early geological history. Jonathan O'Neill, a geologist at the University of Ottawa and the study's lead author, noted that Hadean rocks are extremely rare due to the recycling of Earth's crust through tectonic plate movement. The Nuvvuagittuq rocks present a unique opportunity to examine the conditions of early Earth, including the transition from magma oceans to tectonic plate formation and the possible origins of life. The ongoing debate about their age highlights the critical need for careful evaluation of dating methods, particularly those that significantly impact our understanding of Earth's history. A new portable gene therapy device, nanospresso, has emerged with the potential to transform the creation of personalized medicines for rare diseases. This device, detailed in a recent study published in Frontiers in Science, operates similarly to an espresso machine, utilizing small cartridges that allow pharmacists to mix patient-specific therapies on-site through a microfluidic system. Nanospresso enables the precise combination of ingredients such as genetic material and fats, resulting in targeted medicines that can be directly injected into patients. The project is funded by the Netherlands Science Agenda and seeks to enhance access to advanced therapies while adhering to strict quality and safety standards. Currently, rare diseases affect approximately 300 million individuals globally, with many remaining untreated due to high costs and limited demand associated with centralized drug production. Researcher Raymond Schiffelers from UMC Utrecht emphasized that nanospresso could help bridge the treatment gap for these rare diseases, which often face challenges in drug development. The integration of nanospresso into existing healthcare systems raises significant regulatory questions, prompting discussions among researchers, regulators, and drug developers. While the device shows promise, it must navigate challenges related to safety, quality standards, and regulatory approval for individualized treatments. This innovative approach aims to deliver low-cost, bespoke gene and RNA therapies, making precision medicine more accessible, especially in low-resource settings. Led by Professor Raymond Schiffelers, nanospresso seeks to decentralize therapy production, allowing for personalized medicines to be produced right at the point of care. Future applications could include precision oncology and rapid responses to emerging pathogens, significantly enhancing the delivery of tailored therapies. Nucleic acid therapies, which target genetic instructions related to faulty protein production, can be adapted for various diseases, including inherited disorders and certain cancers. Recent research has significantly redefined the role of mitochondria, traditionally recognized for their energy production capabilities. These organelles are now understood to be critical players in the immune system, acting as sensors that respond to bacterial activity. Mitochondria not only assist in energy production but also play essential roles in immune functions, including inflammation control and responses to infections. A key finding shows that mitochondria in neutrophils can detect lactate, a byproduct of bacterial metabolism. This detection triggers the formation of neutrophil extracellular traps, or NETs, which are vital for ensnaring and neutralizing invading microbes. However, if mitochondria fail to sense lactate, NET production is significantly impaired, resulting in increased bacterial escape and proliferation, highlighting the importance of mitochondrial function in immune defense. The research also suggests a troubling link between dysfunctional mitochondria and weakened immune defenses in autoimmune diseases like lupus. Patients with lupus often struggle with recurrent infections due to ineffective NET formation, underscoring their heightened vulnerability. This connection emphasizes the challenges faced by lupus patients, who may experience more frequent infections as a result of mitochondrial dysfunction. The findings open potential therapeutic avenues, indicating that drugs designed to enhance mitochondrial sensing could improve immune responses in individuals with compromised immune systems. Additionally, the study encourages further investigation into whether other immune cells utilize similar mechanisms to respond to bacterial byproducts, which could inform new treatment strategies for infections and autoimmune conditions. Overall, this research highlights promising new avenues for treating infections and autoimmunity by targeting mitochondrial functions, positioning mitochondria as vital components in understanding and potentially treating immune-related conditions. Scientists at USC and Caltech, in collaboration with the startup Calkorea, have developed a shipboard system that could potentially reduce shipping emissions by up to 50%. This innovative technology converts carbon dioxide from ship exhaust into a safe ocean solution, addressing the maritime industry's contribution to global greenhouse gas emissions, which accounts for nearly 3% of the total. Current methods for reducing shipping emissions, such as low-carbon fuels and electrification, often prove impractical for long-distance travel. The new system provides a valuable complementary strategy by mimicking a natural ocean process to convert CO2 into bicarbonate, a stable compound that can be safely discharged back into the ocean. The ship-scale reactors are designed to occupy less than 1% of a vessel's total volume and would require about 12 shipping containers of limestone daily for a 10,000-container vessel. The system creates turbulence to mix treated water with surrounding seawater, effectively preventing CO2 from escaping back into the atmosphere. Calkorea is actively working to commercialize this technology and is in discussions with shipping companies to test it in real-world scenarios. Lead researcher William Barrelson emphasized the simplicity of the design, which allows for significant emission reductions without major overhauls to existing ships. Laboratory experiments have shown conversion efficiencies of 20 to 35% under controlled conditions, with a counterflow design achieving 74% instantaneous CO2 removal. Advanced ocean modeling indicates that returning bicarbonate-rich water has a negligible impact on ocean pH and chemistry, with changes remaining within natural variation ranges. The potential widespread adoption of this technology could significantly impact global emissions, although full implementation will require time and collaboration with industry partners, including a partnership with Lomar Shipping's Corporate Venture Lab. Astronomers have made a groundbreaking discovery using data from NASA's James Webb Space Telescope, focusing on the structure of disk galaxies. Their research centers on over 100 edge-on galaxies that existed up to 11 billion years ago, marking a significant advancement in our understanding of galaxy formation. Lead author Takafumi Tsukui highlighted the Webb telescope's capability to detect faint, ancient stars, which enables detailed measurements of disk thickness and structure. This study represents the first comprehensive analysis of thick and thin disk structures across such vast cosmic distances, connecting ancient galaxies to the history of our own Milky Way. The findings support the theory that thick stellar disks form before thin stellar disks, with the timing of their formation being dependent on the mass of the galaxy. High-mass galaxies were found to have formed their thin disks around 8 billion years ago, while low-mass galaxies did so approximately 4 billion years ago. The research indicates that massive galaxies convert gas to stars more efficiently, leading to the earlier formation of thin disks compared to their low-mass counterparts. Despite this, thick disks continue to grow over time. Additionally, the study uncovered the early emergence of thin stellar disks at high redshift, shedding light on the formation history of galaxies. The team examined gas motion data to understand the transition from single to double disk structures, aligning with the turbulent gas disk scenario of galaxy formation. These findings support the notion that a turbulent gas disk results in intense star formation, leading to the eventual stabilization of gas and the formation of a thinner disk. Future studies are planned to incorporate more data on stellar motion and age, which may further clarify the formation history of the Milky Way by examining analogous early galaxies. The results of this significant research were published in the monthly notices of the Royal Astronomical Society, showcasing how Webb's capabilities provide unprecedented clarity in observing early galaxies. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. We'll be back Monday with everything you need to know.